Some series to integral calculus. Some series to integral calculus in which we are proceeding the discussion. Whatever we have taken the series, solution is available, but it is not through the integral calculus though. Okay, whatever we have done, solution is available. May not be through integral, what may not be? It is not through integral calculus at all, but solution is available. I was searching for Fibonacci series, then I could not find solution addition of Fibonacci series. Fibonacci series is a series which is Fn equal to Fn minus 1 plus Fn minus 2. It is heavily used in demonstrating the recursive program in computer science. At the beginning of recursive program, these are the things that is come into the picture. How you can compute a Fibonacci series, where at any moment, if I have consider I have a slots, I have x-axis and I have slots. Slot means x equal to 0, x equal to 1, x equal to 2, x equal to 3, and so on. This is a slot on x-axis. Understandable, right? I have x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5, and so on. Okay, these are called slots. Slot number 0 has a value of 0. Slot number 1 has a value of 1, that is fixed. Slot number 2, slot number 2 has a value of previous two slots addition. What is the value? Value is considered as y-axis. If I have slots along x-axis, then against each slot, whatever value I have, that value corresponds to vertical y-axis. If this is x-axis, this is y-axis. X-axis talks about the slot number and y-axis talks about the value in the slot. I believe it is understandable. When x equal to 0, then slot value, that is the y-axis function over x, is 0. When x equal to 1, then function over x is 1. This is fixed. When x equal to 2, then function over x, that is the vertical amount, that is fn, function f, or better we can say fx, function over x, fx equal to fx minus 1 plus fx minus 2. Then the value in slot number, if I start with slot with 0, consider I slot with 0. Okay, if I slot with 0, then 0, 1 is fixed. Slot number 2 will be previous two slots addition. It will be 1 again. It will be 0, 1, 1. Slot number 3 will be addition of slot number 2 and 1. That will come as 3. Of 2. 0, 1, 1, 2. Slot number 4 will have addition of previous 2. That will come as 3. 0, 1, 1, 2, 3, 5, 8, 13, and so on. This is called Fibonacci series. Can I compute addition for any n terms? N terms means slot number will be n minus 1. If I said 3 n equal n terms and n is 3, then slot number it will go up to 2, 0, 1, 2. Someone can adjust it and he can start slot number from 1 only. Then it will become n minus 1 whatsoever. This is how it is. So this is called Fibonacci series. To compute the summation of Fibonacci series, someone would ask, can you compute the summation up to slot number? Slot number 10 means it will start from slot number 0, 1, 2, 3, 4 means 11 number. Total 11 number or n equal to 11, where n is the number of items, or slot number 10, whatever is handsome, whatever is the handsome person can understand. In that manner, how someone can calculate the addition. This will be very big number, I believe so. Okay, then fx equal to fx minus 1 plus fx minus 2. That would not work with integral calculus. Or if it works, then someone has to think more on it. What it works is, can we have at any slot n equal to x? At any slot x, where x starts from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, x. At any x, what is the value I expect in terms of x? That is what we want. Okay, I have not seen how it comes, but luckily we found that it is pi is a number, pi to the power n minus minus I'm sorry, pi 1 to the power n minus pi 2 to the power n divided by square root of 5. This is what I was saying. If where n is the slot number begins from 0. So if slot number is 0, then pi 1 to the power n minus pi 2 to the power n. I'm sorry if I have said minus n, it is wrong. To the power n, pi 1 n minus pi 2 to the power n by square root of 5. If it is 0, then 1 minus 1 by 0, it is 0. Slot number 0 is 0. If it is 1, then pi to the power 1, that is pi 1 minus pi 2, because power is 1 1. So pi 1 minus pi 2 by square root of 5. A square root of 5 would come, I believe, around somewhere around 2.22, something like that. I think so. 2.22. Okay, I think so. 2.22. 22 into 22, how much it will be? 22 into 22, 44, 4. 44, 4 again, 48. 484, 4.84. Okay, if I take 2.25, if I take 2.3 into 2.3, 23 into 3 will be 69. 9 and 6, 23, 46 and 6, 51. It is crossing. Okay, I can take 2.25, something like that. 2.25. So the Fibonacci series someone has computed, and this is called magic number. Pi is called magic number. What is pi 1? Pi 1 to the power n minus pi 2 to the power n divided by a square root of 5. If n is slot number is 1, then pi 1 minus pi 2 by square root of 5. What is pi 1 and pi 2? Pi 1 is pi 1 is up up up. Pi 1 is up up up. What is pi 1? Pi 1 is 1 plus a square root of 5 by 2. 1 plus a square root of 5 by 2. Pi 2 is 1 minus a square root of 5 by 2. 1 plus a square root of 5 by 2 would come how much? 1 plus 2.25. That will come at 2.25 by 2. Okay, it will 2.25. It will come as 1 up. 2.25. 1 point up. Okay, we'll try again. Okay, square root of 5 is 2.25. 2.25 plus 1, 3.25. 3.25 by 2. That will come as 1.62. Okay, 32 by 2 is 1.6 and 5, 2. 1.62. 1.62 minus 1 minus a square root of 5 by 2. That will come as 1 minus a square root of 5 will come as minus 1 minus 1.25 by 2 minus 62. Minus 62. Here it is 1.62 and there it is minus 62. Net computation is 1.62 to the power n minus, and in bracket, minus zero point 0.6 to the power n divided by 2.25. This is what is the net. This is what is the net Fibonacci series. If n equal to 1, then 1.62 minus to the power 1 is minus 1, minus plus 1.62 plus 2.62. That will come as more or less 1 point, that will hope that will come as more or less 2.25 by 2.251. If n equal to 2, then 1.62 whole square minus, and then minus whole square will be plus. So minus 0.62 whole square, that will come around zero point 0.4, I believe. So this side 1.62 whole square, how much it will come? 1.6 whole square, 1.6 into 1.6. Okay, 16 into 6 is 96. 6, 9, 6, 9, 25, 2.56. 2.6, 2.6, this is what I think. So 2.6 and then minus, because square minus a square will be plus, minus 2.6 minus a square of 0.62, that will come as zero point 0.4. More or less it will come as 2.25 by 2.251. Means slot number 0 is 0, slot number 1 is 1, slot number 2 is 1 again, slot number 3 1.62 to the power 3, that will come as 2 point, how much we had come, I forgot, 16 into 16, 96, 925, 2.6. 2.6 into 1.6 again. 1.6 means 1.5. 2.6, 1.5 will be 3.9. 4. Around 4. Minus 1 to the power 3 will be minus, 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 plus. 4 plus 4 plus zero point 0.4, 4 plus zero point 0.4 into zero point 0.6. It will be more or less half to it. 2.22, something like that. So 4 plus zero point 0.22, 4 point, hope it will come as kind of 4, okay, 4.3 around, 4.3 by 2.25, more or less it is 2. So when n equal to 3, slot number 3 it is 2. So 0, 1, 1, 2. Slot number 4. Slot number 4, if I compute, this side we have 4, around 4. I think it will be more than that. 4.1. 4.1 into, or 4.2. 4.2. Keep 4.2. Earlier we had 2.6. 2.6 into 1.6. 2.6 into 6, how much it is? 6 is 36, and 6, 12, 15, 16. 2.6 around 4.2. I was right. So 4.2 into 1.6. 4.2 into 1.6. It will come at, I believe, 6.5, something like that. 4.2 into 1.5 will come as 4.2 plus 2.1. 6.3. 6.5 or 6.6. 6.6 minus 1 to the power 4 will be positive, so negative. 6.6 negative, and zero point 0.6 to the power 4. Okay, zero point 0.6 whole square will become 0.4 around. 0.4 into 0.4, it will be 0.16. 0.16. So 6.6 minus 0.1, 0.16. More or less, it will come as 6.5 or something like that. 6.5. 6.5 or 6.6 by 2.25, it will come as 3. So when slot number 4 we are taking, it will come as 3. 0, 1, 1, 2, 3. Perfect. We'll take one more. Slot number 5. If I take slot number 5, 6.6. 6.6 into 1.6. 6.6 into 1.5 will be 10. 6 and 1.5, 33 will be 10, around 10. 10.5 I can take. 10.5 and minus 1 to the power 5 will be negative, 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 plus 10.5 plus plus. Now we had 0.16. 0.16 into zero point 0.6. It will come as 0.1, I think. It will come as 0.1. So now we have 10, 10.5 plus 0.1, 10.6, something like that. 10.6 divided by 2.25. It will come as 5. 5. 1, 0, 1, 1, 2, 3, and 5. Perfect. So whoever has deduced this, I have not deduced it. Whoever deduced this algebraic formula, he is perfect. God has given more brain than anyone else like us. Okay, whoever has done this. Phi 1 to the power n minus phi 2 to the power n by square root of 5. Now, can we use this algebraic equation to calculate the Fibonacci series, addition of Fibonacci series, where we will take n number of terms. If we take n number of terms, then the last slot number will be n minus 1. Makes sense? Or this is how it is, because it starts from 0. If I say it starts from 1, okay, then n number of terms, because 0 will not come into the calculation anyway. So if I talk about the summation, then it will be n number of term we take, then how much it will be. Okay, but the formula will be different. If I exclude 0, then it will be phi 1 to the power n minus 1 or n plus 1. If I take first term as no, nothing will be. Nothing will be. Where phi 1 to the power x, where x starts from 1. Makes sense? Phi 1 to the power x minus phi 2 to the power x by square root of 5. This is the formula. Can someone compute this addition? Okay, we can go with the successive approximation. Directly repeated addition would not give the exact result. If I go with the successive approximation, then how we can compute? Okay, if I go with the successive approximation, the way I am talking, if this is x-axis, we will start with x equal to 1. Then fx is phi to the power x plus phi 1 to the power x minus phi 2 to the power x by square root of 5. When x is odd number, then phi to the power x is always positive. Minus phi 2. Phi 2 is negative. Negative to the power odd number will result in negative. Makes sense? Negative and outside negative. It will always be positive. Always be positive. So I would rather say if x is odd number, then I can say phi 1 to the power x plus phi 2 to the power x. What is phi 2? Phi 2 is different now. Earlier phi 2 was 1 minus square root of 5 by 2. Now phi 2 is a square root of 5 minus 1 by 2, because it will be always positive for odd number. So we can say 1 plus a square root of 5 by 2 to the power x plus a square root of 5 minus 1 by 2 to the power x. This full term is positive now by square root of 5. If I have this algebraic equation for odd number, means x equal to 1, x equal to 3, x equal to 5, x equal to 7, can we compute the addition up to x equal to n? If that is the case, then what about even number? Even number means phi 1 power x minus, this is original one, phi 1 to the power x minus in bracket phi 2 to the power x. Phi 2 is negative. If I talk about even number of x, then negative x will become positive. Outside negative is waiting. So it will always be negative. Always be negative. So it will come for even number, it will come as phi 1 to the power x minus phi 2 to the power x by square root of 5, where phi 2 is modified. What is phi 2? Is a square root of 5 minus 1 by 2 by 2. This whatever we are talking, it is not available in any of the book. Anyone can try. Okay. So it is phi 1 to the power x minus phi 2 to the power x by square root of 5. Okay. If that is the scenario, then for even number, for any slot x, where x is 2, 4, 6, 8, 10, and so on, any slot x, the formula is phi 1 to the power x minus phi 2 to the power x divided by square root of 5, where phi 2 is square root of 5 minus 1 by 2. Phi 1 is the square root of 5 plus 1 by 2 whatsoever. Now, can someone compute these two separately and merge it? Okay, we will go to our previous example where we had taken example of merging it. If people remember, we to alleviate it, to make it easy, we had started with a discussion where we are adding 1 minus 2, 1 minus 2, and then there are slots x equal to 1, 2, 3, 4, 5, 6, 7, 8 on x axis. When x is 1, then it is 1. When x is 2, then it is minus 2. When x is 3, then it is 1 plus 2 plus 3. Addition of 3 terms. When x equal to 4, it is minus 4. When x equal to 5, it is 1 plus 2 plus 3 plus 4 plus 5, something like that. When x equal to 6 minus 6. Now to solve this problem, we segregated the even odd number and even numbers. Odd number is now 1, where slots are x equal to 1, 3, 5, 7, 9, and so on. For even number, slots are x equal to 2, 4, 6, and so on. Now for odd number, I have function is x into x plus 1 by 2. Means if I take x as 5, slot number 5, then 5 into 6 by 2, that will come as 15. Number is 15. Means 1 plus 2 plus 3 plus 4 plus 5 is 15. Please watch our previous 3 to 4 videos on it. Means we have x into x plus 1 by 2 is fx for odd number. Okay, if I want successive approximation, we tried it where we take area. Please watch our previous video how successive approximation works. This is our principle. In that manner, if I have a, if I have a kind of a vertical, if I have a discrete function as x into x plus 1 by 2, then at x equal to 1, 3, 5, 7, I have verticals. I have vertical. If I have vertical, if I connect all the top points, then it draw a line, and that line is function over x, and that line is function over x. Okay, if that line is function over x, if that line is function over x, if I connect, that is x into x plus 1. If I take, okay, if I have a vertical at x equal to 1, 3, 5, 7, and so on, this vertical will be matchable to area between x equal to 1 and 3. If I take one area strip and this area strip go and hit a function called gx, another g, that I don't know, that is a continuous function. If I have in fx, if I have so many vertical, with each vertical I have area, sub area. So first sub area is from x, from if it is, starts from 1, then 1 minus 2, because between each sub area there is gap of 2. If I take left hand side sub area, then it will be minus 1 to 1, 1 to 3, 3 to 5, and last one will be n minus 2 to n. Okay, I have to find fx so that each sub area will be equal to the right hand side fx. Means fx at x equal to x is x into x plus 1 by 2 equal to limit x minus 2 to x gx dx. Okay, in that manner we try to find it. What is gx? For which gx dx x minus 2 to x will be fx at x equal to x, that is x into x plus 1 by 2. Okay, I'm trying to remember what we did in the last session. So there I believe that gx what we got was x square by 4 plus 3 by 2, 3 by 4 x, 3 by 4 x. Okay, and then plus 5, sorry, minus 5 by 12. This is what I remember. We'll try now with this gx. Dx is x square by 4, x to the power 3 by 12, x to the power 3 by 12, x to the power 3, x minus 2 to x. If I do, x to the power 3 will be okay, x to the power 3, x to the power will go away. Okay, it will become 6x square minus 12x plus 8. X minus 2 to the power 3, it will be minus 8 plus 8 by 12. That will be x square by 2. minus x plus 8 by 12 or 2 by 3. This is what I remember. Now plus 3 by 4x. X integration will be x square. 3 by 8 x square. X square, x minus 2 to x, that will become x square minus x minus 2 whole square. Okay, that will become x square minus 2x plus 4. That will become 4x minus 4. 4x minus 4 by 8 that will become 3 by 2x. 3 by 2x minus 3 by 2. 3 by 2. So we have this side, we have x square by 2 minus x plus 2 by 3 plus 3 by 2x minus 3 by 2. 3 by 2x minus x will become 1 by 2x. This is what we want. X square by 2 plus x by 2. Now this is frozen now. Now we have 2 by 3 minus 3 by 2. Negative is more. To compensate that last term, we have to make 5 by 12. Okay, 5 by 12. Now it is perfect. 5 by 12. 5 by 12 x minus 1 to x, that will become 2. 5 by 12 into 2, 5 by 6. Now the constants are 2 by 3 minus 3 by 2 plus 5 by 6. If I take 6 as denominator, 2 by 3 will become 4. 3 by 2 would become 9, and 5 for all will go away. So gx we have taken as x square by 2, x square by 4 plus x by 4 plus 3 by 4x plus 3 by 4x plus 5 by 12. Okay, now if I am computing, this is to settle down n. If I am computing the n terms, then n term we start with the 1. If I start with the 1 and left hand side area we have taken, it will start from 1 minus 2. So integration 1 minus 2 to n. 1 minus 2 to n. It will come as minus 1 to n gx dx, where gx is x square by 4 plus x by 4 plus 5 by 12, just 5 by 12. Integration will be x to the power 3 by 12 plus x square by 8 plus 5 by 12x minus 1 to n, that will become n to the power 3 plus 1. N to the power 3 minus 1 to the power 3 will be plus 1 only. N to the power 3 plus 1 by 12 plus n square minus 1 by n square minus 1 by by 8. Okay, x by I'm sorry, it is 3 by 2x, 3 by 4x, 3 by 8x square. Okay, x square would become n square. Okay, this is how it is. 3 by 8. First is n square plus n to the power 3 plus 1 by 12 plus 3 by 8, and in bracket n square minus 1 plus 5 by 12, and in bracket n square plus 1 minus 1 plus 1. This is what the computation of all odd numbers. Let's take computation of even numbers. Even numbers are 2, minus 2, minus 4, minus 6, minus 8. If I don't consider minus, just take for plus only, then function over x is x. Where slot number 2 is there, it is 2. Slot number 4 is there, it is 4. So x equal to gx dx, x minus 2 to x. I believe we had got gx dx as x by 2 minus 1 by 2. This is what I remember. We'll try. X by 2 integration will be x square by 4. X minus 2 to x will be x square will go away. It will become 4x minus 4 by 4. X minus 1. This side we have taken 1 by 2. 1 by 2x. X means x plus, that will be only 2 will remain. 2 by 2 is 1. X minus 1 plus. Perfect. Okay. So gx we can take here as x by 2 plus 1 by 2. X by 2 plus 1 by 2. Okay. then it will give perfect result. So we can take now limit will be, since it starts from 2, 2 minus 2, 0, 0 to n. So it will start 0 to n. Gx is x by 2 plus 1 by 2, x square by 4 plus 1 by 2, x 0 to n square by 4 plus 1 by 2n. Someone can try. If I take n as 8, n square by 4, 64 by 4, 64 by 4 plus n by 2, 8 by 2. Okay, that will become 16 by 4. 64 plus 16, 80 by 4, 20. That is perfect. 20 will be the result. 2 plus 4 plus 6 is 12 plus 8, 20. Okay, means now we have two terms, odd summation and even summation. Odd summation is n to the power 3 plus 1 by 12 plus 3 by 8 bracket n square minus 1 plus 5 by 12 and in bracket n plus 1. This is for odd number. For even number, we have now, for even number, we have n square by 4 plus n by 2. This is for even number. Okay, now if I settle it down, even number we have taken positive, positive, but it is negative actually. So negative we will put at the front. So net computation will be n to the power 3 plus 1 by 12 plus plus 3 by 8 in bracket n square minus 1 plus 5 by 12 in bracket n plus 1 minus, and then numerator is n square plus n square by 4 plus n by 2, n square by 4, n square by 4, this is what I remember, n square by 4 plus n by 2. Now, will it give the result? It will not give the result. Why it will not give the result? Because both places n are different. Here n is odd and here n is even. They should be same. Now, if in examination, if it is written that I want to compute 1 minus 2 plus 1 plus 2 plus 3 minus 4 plus 1 plus 2 plus 3 plus 4 plus 5 minus 6, like so up to 33, means odd number is the highest one. So this n, if I take it as a reference, n odd number n as reference, then even number n is one less than odd number. So n I have to resettle it down. So we have n square by 4 plus n by 2. Instead of n, I will write n minus 1, where that new n is odd number n. Now both we can merge now. N square plus 1 by 12, n to the power 3 plus 1 by 12 plus 3 by 8 and in bracket n square minus 1 plus 5 by 12 in bracket n plus 1 minus, and numerator will be n minus 1 whole square by 4 plus n minus 1 by 2. If someone merges it, this is the summation result where n is odd number. People can try where n is even number. Means maximum term is not up to 33, up to 34. Someone can try. If someone cracks it down, then he can crack the summation of Fourier series. I'm sorry, summation of Fibonacci series, which is not available in any of the book. Anyone can try. With this approach, someone can indeed calculate the summation of Fibonacci series. Okay, someone can try. Please not mind supporting us. +91 is the India country code 9483160610 telephone number. +91 is India country code 9483160610 is the telephone number. -1 to the power x, neither differentiation nor integration is available. It will come in complex number if someone try directly, but we are able to achieve it, head hitting in the wall.